Hello everyone. I am Kareem El-Safty. I live in Egypt. I'm from Egypt. I am 26 years old. I have a bachelor degree in communications and electronics engineering. I am an AI engineer at Division X company and also a research assistant at Wigner Research Centre for Physics in Hungary. I'm also a research member in Alexandria Quantum Computing Group in Egypt. I started doing my master's degree at Suez Canal University, especially in computer engineering. I'm also a Qiskit advocate. I'm a certified analyst from IPM. Some achievements that I have made, like in the last year, I won a national grant for Udasty's AI nano degree. Currently, I'm preparing myself to be a machine learning teacher at Information Technology Institute. It's like how can I say this? Like an initiative from the Ministry of Communications and Information Technology to enhance and to like narrow the gap between academia and industry. I'm also preparing for the AWS Certified Machine Learning Specialty exam. And I forgot to add this last word. I'm sorry about this. I love rapping, especially the rapper Eminem, and also some trance music. So I'm sorry about this last one. I'll edit it and then send it to you. So my journey to quantum computing. First of all, it all started in primary school. Actually, in the third year, to be precise. I didn't like mathematics at all and still don't like it, but science classes were like my main thing. I loved chemistry and physics a lot since I was a kid. I hated summer vacations because it kept me away from some special people, and I didn't like to be alone in the summer, and school was everything to me. So just like a nerd boy, I wanted to understand why we can't do time traveling or to make time stop whenever we need. So I started Googling, and that was like around 2003, and Google was like a new thing. And also our internet provider or service provider was extremely slow. I mean, like the struggle was real, and the speed was like was like around 5 to 10 kilobytes per second, so it was extremely slow. But at the end, I met those two terms, the E equal mc squared, and this lovely equation, as you can see here, this tensor equation about general relativity and this one about special relativity. Of course, I felt absolutely dumb and stupid. So one doesn't simply walk into physics, especially when you are very young and also don't know anything about how to conquer this realm. So I start reading a lot, everything that I got my hands onto. But first of all, the language was a problem for me. Just a second, there's someone else who wants to join. Okay. The language was a barrier for me because English is not my first or my mother tongue language. Arabic is the one. So that is my first problem. The second problem is that most of the translated books are not like very professional. They only translate everything like literally, the translations into like literal translation. I mean, the meaning itself is not that self-explanatory when you read it in English, for example. So that was another problem for me. But like when the years, I mean, like by time, and of course by the help of my teachers and my grandfather, everything started to be more clearer for me by time, and I started to like physics more and more, and it got me hooked. For example, it was like my best friend and also my single passion or my whole passion. And I decided to be a physicist when I grow up, but that actually didn't happen because to be a physicist in Egypt, it won't give you like a lot of money, or it will not pay off like a lot at the end. So I had to do engineering, and the only department that has a lot of things or a lot in common with physics is communications and electronics. We had to study like around 3 courses for physics, or in physics, I'm sorry, and also we studied like around 8 courses of math. So somehow engineering got me or helped me in a lot of aspects about calculus and also linear algebra. Besides, we studied like not into much details, but a little bit about quantum computing for solid state electronics, and that helped me a lot to understand the basics of quantum mechanics. But the main 3 contributors for my learning journey was edX and MIT OpenCourseWare and Coursera. If we want to talk specifically about these ones, I do actually recommend the following courses: 8.04, 8.05 and 8.06. These 3 courses are about quantum mechanics. They are offered from MIT, and they are also hosted on edX platform. 8.04 is more than enough for anyone who wants to know quantum mechanics or quantum physics in general, and also it would be a very good basic for anyone who wants to know the quantumness behind quantum computing itself. There is another course on Coursera where like I believe that Coursera was founded like around 2012. Around 2012. So there was a course at that time which is called Exploring Quantum Physics, and right now Coursera started again to present the same course. It was a very good course, and it has like mixed levels of experiences, so you should be careful when you watch this one or take this one. There is another wonderful course which helped me a lot in my journey, which is called Quantum Mechanics for Scientists and Engineers. The platform that used to host this one, it's right now it's out of service. It is out of service. It was Stanford platform for OpenCourseWare, and it's not live anymore. Actually, the Quantum Mechanics for Scientists and Engineers currently is presented on edX, or hosted on edX. It is a very simple one, and it doesn't assume like a lot of prerequisites, and it serves like a broad and general audience for different disciplines. For example, if you are a computer science engineer or communication engineer or mechanical engineer, or even like a biology engineer, it will help you to jump in and study quantum mechanics easily. The other courses, machine learning and deep learning. First of all, I didn't like engineering while like starting from 2012 when I started university up until 2017. In Egypt, it's a 5-year journey, so I decided to do machine learning for living because of 2 things. The first one is that it is very related to quantum computing in a sense that we can actually combine quantum computing with machine learning. So there is this field which is called quantum machine learning. That is the first thing. So machine learning for me, it's not only about getting paid or something like this, but also it is my gateway for achieving my passion about studying physics in general, and quantum physics in specific. So I actually took several courses from Coursera and edX about machine learning and deep learning, and other courses, of course, for software engineering, because we didn't focus on these courses in communications and electronics. So in a sense, you can say that most of my experience is built on online learning or e-learning. After I graduated, like in 2017, I spent some time because of military services, and then I joined the Vision X company. It is a computer vision company based in Egypt, Cairo, and we have several projects mainly about machine vision systems. For example, like quality inspection, instead of like the normal quality inspection routine or system where you have a human who can check your products, we simply install like a vision system consists of a single or multiple cameras, and then do everything that the human can do. For example, checking if there are any defects in textile in the industry, or check, for example, like in the last couple of weeks, we were working on face masks defects. If there is, like, for example, like some pores in it, or the wings of the face mask itself is not like connected, or there are several cuts. Okay, so we are searching for defects in the product itself using only cameras, and based on the solution and of course the hardware from the customer, whether they want to deploy an advanced solution, for example using deep learning, or simply enough image processing techniques that fits their own computing power. We are also working on like a bit different tool, which is I'm sorry about this noise, about AI, or automating the training services for computer vision. For example, you can simply enough upload your data, and if you want to label them, you can do that easily, and then we will take it from here and build the model for you, customize it for your own hardware, and then deliver it to you as an API, for example, like a Docker, yes, like a Docker, or for example, give you the model itself, like the raw model or the raw weights, and then you can use it in your own pipeline. We can also do this for other datasets, not only for image, but also for text data. So it is automated machine learning services. It is called Tuba, and it is expected to be out to public like around January or February. We are going also to support not only classification, but also object detection and segmentation. So I am the leader of this product, and I hope that it will succeed in the future. In 2020, I also joined Wigner Research Centre for Physics in Hungary. Like around, it was in April, actually. It was in April. I actually was very proud to be part of this organization, and I'm currently working on quantum photonic systems. First of all, when I started to learn about quantum computing, everything was like around zeros and ones, and that's it. But quantum photonics is completely different. It is continuous, and you describe your own system in terms of something called the mean vector and the covariance matrix, and that is something that is not that trivial, but with time you will get accustomed to it, and you can do a lot of things inside the quantum continuous variable system, because there are some features in this system that does not, or I mean that don't exist in the qubit system. For example, there's something called the cubic phase gate or the Kerr gate, and these gates are not linear in the sense that they actually make something called the Wigner function to have, or the Wigner probability distribution to have negative values. And that is a nonlinear effect. That is something that you don't usually have in a qubit system, except for some measurements you do. But in the continuous variable system, the cubic phase gate or the Kerr gate or any other higher order Hamiltonians can be constructed using squeezing, squeezing displacement and some phase shifters or beam splitters and a simple Kerr gate or cubic phase gate. Also in 2020, I managed to publish 2 papers. The first one was something called classical and quantum regression analysis for the optoelectronic performance of this huge molecule of NTCDA blah 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 photodiode. I actually don't know the full name of this photodiode. It is a bit hard for me because I wasn't responsible for the preparation of this molecule and also the photodiode fabrication thing. It is a physics or like my colleague and also a professor in the thin film laboratory physics department in Suez Canal University. He was the responsible for this. I was only responsible for the modeling techniques, the classical and the quantum ones. And the other paper was accepted at IEEE Quantum Week. It was like a huge conference that happened, I think, in late September. And our paper got accepted there. It is called Quantum Optimization for the Graph Coloring Problem with the Space Efficient Embedding. We actually managed to reduce the number of qubits to embed a graph into a graph coloring problem into a quantum computer. That is the first thing. The second thing is that we managed to converge faster than using the simple embedding techniques. Yes, the quantum computing community in Egypt. There is a quantum computing group in Alexandria. It is one of the oldest groups in Egypt, and I am a research member there. We have a lot of collaborations with different universities in Egypt. By the way, if you click on the logo itself, you will go to the main page of the group, and you can find that last year we had a summer school and then a one-day conference where you can present your abstract or like your latest work. It's a huge community, and we are very welcome if anyone who would like to collaborate with us or do any research with us. That would be great, actually. Some of the resources that I actually find very useful for anyone who would like to jump into the quantum computing track. The first 3 are simply like 3 books about quantum computing explained by David McMahon, Quantum Computing An Applied Approach by Jack. I think he is from the X-Moon Factory, which is a sub-company in Google, and the book is extremely amazing, and it is very applied, and you can use the Google Quantum Library Circ to implement some of the exercises and the examples in the book. The first book is very easy for anyone. Actually, it takes you from like the lowest and the basic level of understanding, and then it builds up every complex and non-trivial concept in quantum computing. It has a lot of solved examples, and it is very useful for an academic approach. The third book is like the holy grail of books in quantum computing, and one of the earliest ones, The Quantum Computation and Quantum Information by Isaac Chung and Michael Nielsen. Some people would love to call them Mike and Ike. So this book actually was my first one, and it made me a bit challenged by the concepts, but at the end I managed to understand a lot of things because of this book. The The fourth resource that I do actually recommend is the Quantum Mechanics and Quantum Computation course. It is by Professor Omish Fadzirani. This course is actually hosted on edX, one of like the earliest courses on quantum computing on edX, and like I think in last August there was like a rerun for this course, and if you cannot like enroll right now in edX, I think that I do believe that it is already uploaded on YouTube, the full playlist of the course. It is amazing, and there is also like a website for it that has all the materials and everything. Of course, since I'm a Qiskit advocate, there is this wonderful textbook, which is also a Jupyter notebook, which is called Qiskit textbook. I do recommend anyone who is very familiar with programming, like in Python or any language, then to jump and start with the Qiskit textbook. The final resource, which is quantum machine learning resources. These resources I gathered them for the Qiskit summer school, and there were a lot of people who were really into quantum machine learning and wanted to understand many things in quantum machine learning. So I gathered almost everything that I know about quantum machine learning in these resources. So I think you might find them very useful. So please keep in touch with me, like on Twitter or LinkedIn, or this is my email, and thanks for listening, and I hope that I didn't like make the presentation a bit longer or something like this. So do you have any questions or anything you would like to know?
Fantastic presentation. I really liked it.
Thank you so much.
I have two questions. The one is, I missed the description of one of the places, the communities in Egypt.
Yeah, sure.
In quantum, that slide, that one, that's it.
Yeah.
Okay, I'll write down.
Actually,
AOQC.
The quantum computing group, Alexandria Quantum Computing Group in Egypt. I will send you the slides, and you are free to you can I, for example, like open other links?
I'm happy with that.
Okay.
I assume it's fine.
Okay, just a second. So this is the main website of Alexandria Quantum Computing Group. Okay.
Mm-hmm.
You can see that here. These are the people: Professor Ahmed Yunus and Professor Ashraf Said. They are the main leaders of the group, and most of the members. And like lately, I was like the new member in this group. I joined them last year. Okay. Here you can find the research. Just a second. I don't know why the internet is a bit slow. I don't know why. Just a second. Or perhaps the server. I don't know. Let me check. Actually, it is the university server. So if you open the link if you open the link from here, if you push this logo here or click on it, you will be directed to the main website. Perhaps it will open faster with you. I don't know. But it is one of the oldest communities in Egypt, and it has a lot of collaborations with different people and different universities. Oh yes, I almost forgot about this. There is also a professor from Ain Shams University. It is based in Cairo, the capital of Egypt. His name is Dr. Ayman Baha, or Professor Ayman Baha. He is working on quantum communication and quantum internet. The main group in Alexandria, or the Alexandria Quantum Computing Group, they work in quantum algorithms, especially Grover algorithm or searching algorithm in general. Who else? Currently, he's living outside Egypt. His name is Professor Ahmed Farouk Mitwalli. He is also working on quantum internet and quantum encryption. He has a lot of scientific publications, and I'm proud to be working with him also. So these are the people or the communities that I do know in Egypt. So what is the other question that you would like to ask?
Sure. Thanks for that. That was great. I now have a note of that as well as the link. The other question is, so I also come from a kind of electrical engineering or electronics engineering background.
Oh, that's great.
And I found it very useful to have that foundation getting into quantum. Also, one of the things that we covered in our undergrad was the quantum physics or quantum mechanics of semiconductors. That's kind of necessary
that is
in
correct.
Electronics.
Yeah, that is correct. Yeah.
But did you find any other benefit from that foundation? And I ask because at my university and in South Africa as well, we're trying to grow the community, but there's a lot of debate about what is necessary for people to get into the field. So it'd be great to have your opinion on what parts of your education and your experience there benefited your ability to get into quantum and to understand it better and to excel in it.
Okay, let's be honest. I had an issue at the beginning, and this issue was that I read, I don't know where exactly, and I don't want to remember anything about this website, but anyway, this website said that it's okay to start quantum computing without understanding quantum mechanics. I was a bit skeptical about this because at the end they said that everything is about linear algebra and that you need only to know complex variables and some postulates of quantum mechanics, something like the entanglement and superposition and then the linearity of the operators and that's it. And I said it's okay. Perhaps the quantum mechanics course that I used to take about semiconductors, then that will be like more than enough for me. And then when I started to think about why these algorithms actually work, or why do we or how, for example, how did Peter Shor invent his algorithm, or how did he improve it, or how did he, for example, move from quantum Fourier transform up until his factoring algorithm. So if you don't understand the quantum physics behind what you're doing, and if you don't have like a very powerful mathematical background, then you will never be able to invent something or to make a breakthrough, or even if you don't have like a very, very strong background in mathematics, but at least you should have like a good imagination and a very good understanding of quantum physics. So a simple quantum mechanics course about semiconductors is not enough to understand the postulates of quantum mechanics, because most of the courses are talking about the Copenhagen interpretation, and the Copenhagen interpretation is like the most well-known one, and It is used in a lot of universities around the world for undergrad or even for postgraduate courses. But there are another interpretations for quantum mechanics. We should know about them. We should understand them, and also we should understand how we deal with different operators in quantum mechanics. We should understand, for example, what is normal ordering, or what does it mean to have like a particular ordering for operators. That is something that currently I am facing because I'm working on quantum Gaussian states, and that is something I didn't find in any course, and that is in like frustrating and also encouraging in the same way to learn new things, but also frustrating that because I thought that okay, understanding like the basics of Schrödinger equation is more than enough, but it's not more than enough. It is barely you're like scratching the surface of the field itself. So if you want to get yourself like motivated, or to say that you are like how can I say this? To say that okay, I can start saying that I am good at quantum computing, then you should at least understand what does it mean to have like some eigenvalues from the Schrödinger equation. That is the first thing. The second thing, you should explain it to yourself, like you should explain it for for a primary school student, or at least like a high school student. You should be able to explain it very well. And also you should, besides understanding the physics itself, you should understand the importance of how to truncate your space, because we are dealing with zeros and ones because we only consider only those two levels, but in reality there are infinite levels in the quantum space, or the phase space itself. So how can we actually move from the phase space to like the binary system that we are only confining ourselves into? So that is something that we don't also hear or learn from online courses. You have to dig deeper into the material on the internet itself. So I don't think that a simple quantum mechanics course about semiconductor physics is like a good start, but it might be for some people, but it's not enough to say that I can take this one and then jump into quantum computing. I don't think so. For some people it might work, but for me it took me a while to understand everything, because I always question myself, and when I start to question myself, I feel like there are a lot of things that I don't know, and that is why I took the approach of programming instead of the mathematics, because whenever I hit the boundaries of something that I don't understand, the mathematics starts to get very, very hard, and there are a lot of things that I didn't study even in undergraduate school. For example, group theory, or Lie group theory, or like the advanced things in numbering theory or set theory. So there are a lot of things in these theories that at least we should know about before saying that okay, we can understand something like the squeezing operator, or we can understand something like Clifford circuits, or how we can do faster or better simulations, or how we can do some correcting codes for the current quantum computers. You should know a lot about group theory and how it actually contributes to quantum mechanics. And to understand something like this, then a simple quantum mechanics course is not enough. It is barely the start of everything. So I'm sorry about this long answer, but perhaps it sums a lot that is actually going on in my mind.
Thank
Yeah,
you.
Kareem,
That was a
I couldn't hear what you said.
I'm sorry, what?
Excuse me. You just. Yeah, you can go. You can go, Kareem.
I can go what?
sorry.
I'm
Thanks.
sorry.
That was a fantastic answer. Thank you. It was great to hear a differing opinion coming from a similar foundation. Because talking to people in my department, they all have a similar opinion that we have a good foundation for people to get into quantum, but I understand that some people may be able to do it and some people may not. I do have to apologize though, but I have another thing that I have to run to. Thank you so much for the presentation. It was fantastic.
You're welcome. Can I stop recording right now?
I think that's fine.
Okay.